Hey Holly, I'm just making this video for you here as I review your first exam from our calculus course, and I just wanted to make sure I talked you through some of the things as well as just give you my written feedback. So first of all, probably what you're most interested in, the score before I reviewed your exam was 53.33%, it's 16 out of 30. After I reviewed your exam for further partial credit, raised it over 20 percentage points, so that's very good. Yet showing me your work and getting that partial credit is really important. We got 73.43% now, and your snapshot overall percentage grade as I looked at it just now, which is I'm making this Saturday morning at about 11:06 on July 25th. So that's a snapshot of your overall percentage grade, which if you want to attach a letter grade to it, you can think of that as a C-/C, somewhere in there right now, but I really strongly encourage you not to think too much about letter grade. I do look at a distribution at the end and take a lot of things into account. So I would never grade harder than what I publish in the syllabus with the Flagler grading scheme, but I certainly have known to move some things around when it seems more fair. So just keep working, do the best you can. All right, so looking at your exam, you got the first 3 questions correctly. There was no work here for number 1, but notice that when you get a question correct with MyMathLab already, I just put check MyMathLab, check MyMathLab MML. That just means that I didn't really look at your work very closely because you already had it fully correct with MyMathLab. Okay, so we get to question 4. Question 4, you had earned a 0.5 at that point out of 1, but the only mistake you'd made here was this g of f of minus 1. So you found f of minus 1 first, but when you plug in minus 1 for f, you get 4 minus 1, which is 3. You left it as 4. So your calculations there on were correct, but you just, I don't know, for some reason you forgot that minus 1. But you definitely seemed to know what you were doing. That wasn't an issue, so I increased your score from 0.5 to 0.9 out of 1. Number 5, small mistake here, I think, was on the if I remember right, it was the part A. So in part A, you have this guy right here, y equals quantity x minus 1 squared minus 1. So you're supposed to think of the parabola x squared. This shifts it down 3 units on the y-axis. So you have the shift down correct. It went down 3 units on the y-axis. So you had that one. But this would be a horizontal shift of 1 unit to the right. So the correct answer is shifting x squared 1 unit to the right, whereas you shifted it 1 unit to the left. So I increased your score on this one gave you half credit for that part A. Each part A is about 0.25, so I went from 0.75 to 0.88. Okay, questions 6 and 7 you had correct all the way already. On question 8, you actually had the correct answer, and you did it right using the double angle identity. You had the correct answer here. This can't be simplified any more than just bringing those 2 fractions together, square root of 6 minus square root of 2 over 4. And for some reason you thought that square root of 6 minus square root of 2 was the same thing as square root of 4. It's not. Okay, so you just had to leave it like this. Alright, but because you really did everything, the calculus part correct that I wanted you to do, really trig part correct that I wanted you to do, went from a score of 0 up to a score of 0.95 out of 1. 9. So in 9 here, this is the first one we actually wanted to find the slope of the curve. You did it correctly. Took the limit, 60 minus 6h, as h goes to 0, you get a slope of 60, which is great, but then you never went on to find the tangent line. If you look at your answer here, you just put in this 60 minus 6h, which was part of your calculation for finding the slope of the tangent line, not for the entire equation. For the entire equation, once you have the slope of 60, then you just use y minus y1 equals m times x minus x1, right? So y1 is negative 146, so y minus a minus 146 is y plus 146, x minus a minus 5 is x plus 5. Simplify that, solving for y, you get y equals 60x plus 154. But I really couldn't increase the score there because that part of the problem was to actually find the equation of the tangent line. And you didn't show me that you knew how to do that at this point. There was no showing me where to get you could do that. So I couldn't increase the score there. 10 and 11, you got exactly correct, so I didn't look at those that close. 12, let's see. 12 was this guy. You just missed part C. So I think it's just a real simple, somehow you dropped the minus sign. You wrote positive 120. Now, I don't see the work up here anywhere, but I'm pretty sure I know what you did, so I gave you credit for that. And since you only missed that one part, your score was already 0.75. I increased it up to 0.90 out of 1. In 13, you did a great job of finding the right graph. Part B here, where it's minus 1/2 and then minus 1/3 is there, and minus 2/7, you got the right graph. So you just need to figure out what's the shortest distance. Clearly by the eye, the shortest distance is this one, from minus 2/7 to minus 1/3. So you found a common denominator, great. You knew what these pieces were, and you thought that negative 12 minus a minus 14 was 2, which is correct, but you forgot the denominator. So 2 out of 42 is the same as 1 out of 21. So delta is 1 out of 21, not 2. You had written 2. But again, you really seemed to show me that you knew exactly what you needed to do, so I increased the score from 0.5 to 0.9 out of 1. 14 was already correct. 15 we have. Okay, so you did a lot of the work here, and actually, this way I look at this, you got it correct. The problem was you wrote the interval as the larger number to the smaller number, which is not how you write an interval. Right? If you look over here, you can see that you wrote the interval from the large number to the small number. Should have been reversed. So you really had that correct. But then, finding delta here, you want to find the shortest distance from that C value of 5 to either one of these endpoints. So this one is 0.5556, or 0.555 if you had more decimals. And this one is 0.7143. So you had that kind of show me that that's right. Something went wrong, and I'm not sure what you were looking at here or anything. So, but anyways, you did pretty good on this problem. You seem to know what to do. So I increased the score from 0 to 0.8 out of 1. 16 and 17, you already had correct. There was no work to look at anyways there. On 18, so you didn't answer anything, but in looking at your work, I really felt like you kind of had the right idea. Tangent of 4x needs to be written as sine of 4x over cosine of 4x. You kind of scribbled it out, but it's there. And you need the denominator to be 4x, because you know you needed sine of 4x over 4x. I think you knew that because that limits 1. But then you have the cosine of 4x still in the denominator, and you have that 4 that you had to put there to get the 4 over 4, to get that 4x in the denominator, so that 4 can come out in front of the limit. So that's what I got going on right here to show you. So the limit as x approaches 0 of sine of 4x over 4x, that's just known to be 1, right? The limit of theta approaches 0 of sine theta over theta. So that's 1. Limit as x approaches 0 of 1 over cosine of 0. Cosine of 0 is 1, so that's 1. So the whole answer is 4. But again, I felt like, okay, I think you pretty much knew what to do here, so I increased your score from 0 to 0.67. 19, you didn't show me any work, and when I look at the problem, it's just graphing it, so I really can't increase the score because I'm not sure what you were thinking, but you got the first part right. Is it defined at 2? And certainly it's defined at 2. It's defined in this piecewise function to be 4 when x is 2, so that's right. Now, is it continuous at 2? All you have to do is look at this, and you say, well, at 2, if I were drawing this with my pencil, when I get to 2, I got to pick up my pencil and go put a dot here, and then come right back down. So no, it's not continuous. It's open on this interval right here, open. So I had to pick up my pencil, come up, draw on this dot, come back down, and continue. That means it's not continuous if you kind of think of the old high school definition of continuity there. So again, I really couldn't increase that, but I wanted you to understand it. All right, so on 20, you actually got it completely correct. You simply, like this last interval here, 7 to infinity, when you look at your answer, you just forgot the comma, and so it marked it all wrong. But I increased it to fully correct, 1 out of 1. So you had 0 before. Let's see, on 21, in 21, I don't think you answered anything again, right? Yeah, you didn't answer anything, but you had some work here. So you wrote secant squared as 1 plus tangent squared. That's fine if you understand how to evaluate. You just didn't actually go ahead and evaluate this. You got to plug in x equals pi over 3, and you got to know that the reason I can plug in x equals pi over 3, in other words, which is the same thing as bringing this limit through inside the radical sign, is because the radical, the square root function, is a continuous function. So that's why we could do that. So then we plug in pi over 3, 60 degrees. Tangent of 60 degrees is root 3. So root 3 squared is 3. So 1 plus 3 is 4. Then I have 4. Tangent of pi over 3 is root 3. These root 3's cancel. I just have 12. So 4 plus 12 squared is 16 is 4. So again, I felt like, yeah, you kind of knew what you were doing, but then you didn't show me. I mean, you knew that you had to make secant squared 1 plus tangent squared, which would help you evaluate it, but then you actually didn't show me that you could bring the limit through and stuff. So there was some things that you did that I could give you credit for, but you really didn't have a full grasp on what to do there. So I went from 0 to 0.33. 22, you got it correct, so no, I didn't look at very closely. On 23, okay, so these are interesting for people. And so what I want you to think about here is when you plug in 7, which you did, you plug in 7, so you get 3 over 0. But you have to think about, we're not really all the way going to 7. We're approaching 7 from the right side of 7. So it's a little tiny bit bigger than 7. That means this is going to get closer and closer to 0, but it's always going to be a slightly positive number, like 7.1 minus 7 is 0.1. 7.001 minus 7 is 0.001. So the way I write that when I'm evaluating the limit is I write 0, yes, like you had, but I put a little positive sign above that to indicate to me, but it's slightly positive. So 3 over a tiny positive number is really infinity. I think you wrote the answer as 0 because you just weren't sure what to do, but I felt like you had the correct idea of plugging in. You got 3 over 0. That's not indeterminate. 0 over 0 is indeterminate. 3 over something close to 0 is infinite. It does not exist. So, but again, I increased the score from 0 to 0.5 on there because you did show me that work. This is a very similar situation in number 24. So you got these B, C, and D correct. So really it's just the limit as x goes to 0 that is messing you up again. Okay, so when you look at these, as x goes to 0, so this numerator goes to 6, right? These are getting closer to 0, that's true. X goes to 0 from the right, that's a really small 0, close to 0, positive number. X is close to 0 but positive, so this will be negative. So this would make you be close to 0 but maybe slightly negative, just like this one does, right? So what happens is, yes, it's 0 minus 0, which is 0, and 6 over 0 is not indeterminate, so we have 6 over 0, but I need to know whether that 0 is slightly positive or slightly negative. So when I plug in 0, x cubed, when it's positive, is really close to 0 but slightly positive. X squared is really close to 0 but slightly positive, but when I multiply by -3 together, this 0 minus 0 is really something that's slightly negative. So it's 6 over a tiny negative number, which is -18. And then when you go to from the left side of 0, you basically have the same type of calculation to get -18, and since it's the same from both sides of 0, the two-sided limit is also negative infinity. Okay? So that's 24. I did increase your score from 0.6 to 0.8 because you were looking up here and I could see you had 6 over 0. You just, again, were not sure about this tiny positive or tiny negative, and you were also thinking of that as indeterminate, which it's not. Okay. The same thing down here. I'm not sure where the 2 came. You're probably looking at an example and thinking of different numbers. All right, so 25. So just so you know, I have to stop my video under 15 minutes because I can't do more than a 15-minute video with what I'm using because I'm using a free version of this video creator. So if I have to create a second video, I will, and I got a minute left. 25 is the last one you showed me work, though. So on 25, again, I'm just kind of cleaning up your notation here, and it's 1 plus h, right? It's f of x plus h, so 1 plus h here. This is great, knowing what to multiply by the conjugate and simplify, and you actually came out, you got -6 for some reason, but I think it's just because you didn't simplify everything correctly. So, and you wrote 6 here, which is the slope, but again, you didn't show me how to find that tangent line. So the tangent line is y minus y1 equals m times x minus x1, right? So you simplify that. But I did increase your score here from 0 to 0.5, but that tangent line calculation is important. That's very important that you can find that. And then the rest of these, 26, 27 through 30, I talked to you about how to go about them, but didn't finish it. All right, I'm stopping the video because I have 5 seconds. Bye.